What is that question?
4.
The famous 4.4 that was nearly forgotten. Like Shem, man, poor thing was forgotten. But anyways, we shall do it.
Are you feeling bad for a question? Wow.
No, I'm not feeling bad for the question. I'm feeling bad for the person that wanted to do the question, but then now the person was almost like they were ignored, and then now it's
I was
like,
never gonna let the session end without my answers. Don't worry about me.
Ooh,
gonna
I'm
let
just
it
trying to
hit.
create. I'm just trying to create space here, create the space.
Let's go.
Paste. Okay, so at the top here. Never mind. You know what? Hey, we'll see. Let me just cut this out also, because I feel like I'm just going to waste time. So, anyways, with 4.4, it says, right, with all that has been done beforehand here. What did we do? Well, we got E and alpha and everything. E, we got it as this was like 16 over 5.
Yes, 16 over 5, 3.2.
And then the gradient here was 5 over 3 using the gradient formula. Here we got the equation of AB. What was the equation of AB again? This one, 5 over 3 and 16, what? Yeah, so the equation of
use
AB.
That one.
Pardon? No, I'm just trying to
use that one.
I'm just trying to make sure that we have all the information that we got from, the previous questions, just in case we may need it for alpha, for theta, because it's a 5-mark question after all. So, 5-mark questions are very demanding, They are like spoiled whatevers, but
spoiled breads.
Let's just give them what they want, Let's pretend they're visitors around and we just need them to get right. So this is 76 degrees. And this one is 59.04. 4. Oh,
yeah,
dang.
I rounded it off to 4.
Oops, sorry, ma'am. Sorry, madam. Apologies. So it says if theta is 76, determine the equation of the line through A parallel to BC. So you see, with these questions, don't get overwhelmed by the wording, because they want first to just break it down. What do they want? They want an equation of a line. Yeah, they just want an equation of a line. So if they want an equation of a line, all they want is practically y is equal to mx plus c. Let me actually just take a screenshot of
figured.
Yeah, which you figured out because you're smart like that, Flex. So anyways, let me just take this down there, because yeah, up here we have no space. Let's do this past there, and then make this bigger. So if you look at what we have, right, or looking at what they're asking for an equation of a straight line. Just read your question in installments. The first thing is they're asking for the equation of a straight line. So this is what you can write out. You can write out this.
I'm going to use that in the future.
Yeah. Wait, use what in the future?
In installments. I've never, you read your question in installments. I've never heard such things.
No, really? I thought I say that all the time.
No.
Because you want to read it, stop, read it, stop, read it, stop. That's how it is. That's how it is. So the idea here now is you just want to know that, okay, they want the equation of a straight line, of which you have, this is what you're going to end up with. But then this is the format that helps you end up with it. This format reminds you that, wait a minute, all you need is a coordinate that the graph passes through, and all you need is the gradient, which is where the next two portions of your question come in, because your question is literally what helps you to answer it. They want an equation of a line. So you want to end up with this, then this is what's going to get you there. Now that you've gotten that part. Yeah.
With that being said, are we not going to use that angle that was provided?
Well, it doesn't look like. We'll see. We'll see if that angle is going to be useful to us. Maybe not. Who knows? We'll see. But it probably is, because look, you see here, we say this is going to help us get the equation of the line. But then now they told us that it passes through A. So them telling us it passes through A is them giving us the coordinate, that the graph is going to pass through. So this is sorted
Mm.
and this is sorted, you see, because A is -5 and -3. This has clearly been given to us because this is going to be x1, this is going to be y1. You see, perfect. Now,
Okay. Mhm.
from reading our question, we can see that, wait a minute, our actual job is to just get the gradient here, because if you can get the gradient, you will have 3 of these things, and then you can end up with the equation that they're asking for. You see, yeah. So gradient being the issue here, this is where this comes in, because they're telling us that whatever the gradient of this line is going to be, you can use BC to help you, because if it's parallel to BC, then it means that the gradient of BC is the gradient of your line. You see.
Oh,
Yeah.
okay.
So even if you want to visualize it, they said we are talking about a line that passes through A parallel to BC. BC is this line here. So the line we're talking about would be down here, looking like that. You see. Well, let me just make it a bit more, yeah. This is the line they are referring to. We need to get the equation of this line here. You see. So our main task is to just get the gradient of BC, which is where the 76 is going to come in, because now it's an angle given, right? What we need to remember is, if you're going to get the gradient of BC, do you see that for BC, you don't have 2 complete coordinates given. You just have 1. So for gradient, you can't use the normal gradient formula. You see, it's not going to work, because the normal gradient formula needs you to use 2 coordinates that the 2 coordinates that do what? 2 coordinates that the graph passes through, you see. So if you're going to, since you don't have 2 coordinates that the graph passes through, I mean, the normal gradient formula should be out of the picture. We cannot use this normal gradient formula. However, because they spoke about an angle being given, you want to consider this formula some way, somehow. Because even though they gave an angle up here, do you see that because of how this question is laid out, remember we said clearly that anything you work out in analytical geometry, it's never alone. Everything here has helped us to get here, because now you have this angle here, you have that angle there. Now here you can see you need an angle of inclination here to help you to to help you to get the gradient of BC. You need this angle of inclination. Yeah, you can see you need this angle of inclination here, because it's going to help you to get the gradient of BC. So us just knowing that, we can already see why these 2 angles are given to us, or why these 2 angles were necessary for us to have. Because as long as we have those 2 angles, I mean, it is so clear to us that, okay, wait a minute, we just need to get this angle here, because this, and this, these are all angles inside this triangle here. Yeah. So let's get this angle here using, what is this? Interior angles of a triangle. So let's just get that first, because we will need it to also then get the blue side. So angle B, what this point? This point was what? E, ne? This was point E.
Yeah.
So angle BCE, let me just write it down here. BCE. BEC, sorry. No, BCE. BCE is equal to 180 degrees minus the 59.04 minus the 76. You see. Since it's analytical geometry, you don't necessarily need to give a reason, but as a habit, you can always just put your reasons, Interior angle.
So giving reasons is not compulsory. Okay.
For analytical, but just use them so that you don't, relax, and then one day it's actually analytical geometry, and then one day it's actually Euclidean geometry, and then now you don't put reasons. So just always put reasons, just so that you can form good habits, and you're gonna be able to recall these reasons easier if you write them out. So this minus this 180 minus these 2, the reason there is just interior angles of
a triangle.
Yeah. So as an answer here, 180 minus 56 No, 59.
44.96.
Yes, 44.96. Yes, 44.96. So automatically we know what this angle is here. The other side. You see, the other side here that's in blue is just 180 minus that answer we just got, which is like 30. Yeah.
I got 135.
Yep. Which is making sense because you see, this is an obtuse angle here. It's an angle bigger than 90.
104.
Yeah,
Okay.
see, visibly it's bigger than 90, so it's fine. Hooray! So you can see here, it's a 5-mark question, and the theme with all 5-mark questions is you don't just jump to the answer, you have to follow a trail. So now we have this angle of inclination, which is now going to help us to get the gradient of our line here, because the gradient of our line is the gradient of BC because they're parallel. So if you're going to use the angle of inclination formula, you have to be careful now. You have to be very careful, because now you know that M, the gradient of, remember, in the angle of inclination formula, the funny thing is the angle of inclination formula will normally give you what you may call, what's the thing? The angle of inclination formula will always give you, I mean, it works with the acute angle. Let me repeat.
Okay.
Or rather, let me maybe find better words to say what I am about to say. But then no, there's no need. You know, there's nothing. There's no reason to say anything shady. Just use the angle here in the angle of inclination formula. So our angle of inclination, we know that we're going to use the gradient of BC, and then we have tan the angle here. We can just say we need a placeholder for this angle. Let's just make it C. Just call it C, tan C. And then here you're going to have your angle, right? Tan 135.04, right?
04.
And then this is like, oh, this is angle, this is line BC. I put B just, so M is going to BC here. Now the unfortunate thing is we have been rounding off here. So for our answer here, we also low-key have to round off. So what's the answer here in the calculator?
The answer. There's no way that's the answer.
No, I was saying, no, I was writing in the calculator 10, and then I put the number. I was saying what I'm writing, not like the answer is 10. Yeah. So what do you get on your side there?
It still can't be the answer. I got a negative.
Yeah, we should, because remember, look, this gradient is a negative. You see, remember, this is giving us the gradient of the line, because now we have the angle of inclination. It's the other way around now. And you see the line BC is going down, so it has a negative gradient, this line. Now, the fortunate thing is, remember, this is like negative 0.99.
0.99.
Yeah, you know, of which we would want to just round this off to -1.
1.
You know, because it's the right thing to do based on what we've been doing here. So now we have a gradient. Ka-ching. We have a coordinate that the line passes through. No.
It should be 7 marks, not 5.
Well, that's the thing, you know, like self-talk is important. So self-talk needs to be accurate. Otherwise, it's gonna mess you up. So if it was a lot of work,
it's 7 marks.
well, I think it's a lot of mark relative to what you're used to in analytical geometry. Remember, it's still fresh-ish, you know. So this feels like a lot of mark now until when you've gotten into the gist of things, where you have like bumped into a bunch of questions, because it's all repetitive, you know, gradient, line, coordinate, gradient, line, coordinate, point, coordinate, distance.
Okay.
It's all the same things, and it's all limited. You know, it's not like English where it's open-ended, you know. It's like how many words in the English dictionary? Nobody knows. I don't even know. You know, so those things are not finite. With math, it's finite. It ends somewhere. I mean, there are literally just 10 numbers in the world, you know, just 10. That's it. You're not gonna get any more. You know, 0 to 9. That's it. Ends there. The rest is just a combination of all those numbers. So That's what you want to just keep in mind. Whatever it is that we're doing here, it's all just going to be the same things. Gradient, tangent, no, gradient, equation of a straight line, point of point, coordinate, midpoint. It's all the same thing, angle of inclination. So a few questions down the line like these, it'll click that, wait a minute, it's all just the same all the time. You see?
Yeah.
Yeah. So now let's just put in all the information we have into this formula. You see, because in this formula we have gradient, which is -1. We have a coordinate, an x value here, which is -5. Or let's just put a plus there. But let's just do this. Let's not be jajara. Let's just take it down here to where we have, some nice space. And then let's just remove what is not necessary. This or this can go now. Not that. Come back, bracket. So we have A, it was -5 and -3. Yeah. And then we have M, which is just -1, because the gradient of BC is the same as the gradient of the line we're talking about. So we can just put that information, x1, y1. So in our formula here, we have to just be careful, you see, otherwise the doll is going to dance. So -3 and a plus, and then here -5 is going to be a +5. You see it?
Yes, yeah.
And then we're going to multiply inside now. -5 here, y plus 3. The 3 goes over. And then here we have -x minus 8. That's the equation of that line that they are talking about. And that is the way we like it. So the idea here is, if you look at the sketch, it kind of makes sense because this is definitely going down. And if the y value here is like -3, somewhere down here, yeah, -8 is believable as the y-intercept. Because remember, in an equation of a circle, this will always represent the y-intercept, the value of c, you see? Y is equal to mx plus c. Ka-ching.
Catching.
Yeah, ka-chow. Ka-chiga, chiga, chiga. Yeah, so that was that for this question. Ka-ching.